The transformation that led to us was no different from other transformations. Our crucial turning point seems to have occurred when our ancestors left the trees and began to walk on two legs.
We don't know exactly when or even where our ancestors became upright and bipedal. We think it goes back well over 4 million years, when these ancestors came out of the trees and began to exploit food sources on the ground in terrestrial habitats. One of the key elements that would have been so useful to them would have been freeing their forelimbs, their hands, to be able to gather and carry foodstuffs over long distances. Once that happened, it opened up an extraordinary breadth of possibilities and opportunities.
Most bipedal hominids went extinct. But one branch went on to evolve larger brains. That branch eventually led to modern humans. So how did this crucial transition to two-legged walking begin? Liza Shapiro of the University of Texas looks for clues in living primates.
When you look at the fossil record, all you have really is a pile of bones. It's a non-moving entity. There's not much you can know about it unless you look for living analogs. So if you look at living animals, you've got the bones, but you can also look at how they're moving.
In their movements, living lemurs resemble tree-dwelling primates that lived up to 50 million years ago. We didn't evolve from lemurs, but they may be the best living analog for those distant ancestors.
When we're trying to reconstruct a scenario about how humans evolved bipedally from this ancestor, we have to know what it was we started from if we're going to come up with an explanation for not only how we made that transition, but why.
Today, Shapiro is gathering data on the movement style of a lemur. Small reflectors have been gently placed on the animal's back. An array of infrared cameras will record the lemur as it walks across this makeshift bridge. Of course, getting a lemur to do just about anything on cue takes a bit of doing.
There you go. Leap up this time.
Finally, the animal makes it across.
There you go. Oh, good.
All right. Got that.
And he's down.
The motion of the lemur's spine can now be analyzed in 3 dimensions. The data reveal that lemur spines are extremely flexible, capable of many kinds of movements.
Lemurs walk quadrupedally, but they're also very good at leaping.
Like these lemurs, the early primates probably moved in all sorts of ways. Down on all fours, scampering up trees, even leaping in an upright position. They weren't limited to just one style of movement, so they could serve as the starting point for a number of evolutionary experiments. And most likely, that's just what happened. We weren't the only ones to evolve from those early ancestors. So did most of today's living primates. Our closest living relative is the chimpanzee.
Stand up.
We didn't evolve from chimps, but we do share a recent common ancestor.
Can you walk over here?
That's why our DNA is nearly identical to theirs, and why our skeletons have the same number of bones arranged in nearly the same way. But the few physical differences that set us apart seem to have made a great difference. Chimps don't walk on 2 feet.
Jewel.
They've evolved a different style of getting around called knuckle walking.
Knuckle walking is a very specialized adaptation that we see among chimps and gorillas today. It's an adaptation to walking on the ground.
Knuckle walking was as valid an evolutionary experiment as two-legged walking. But the difference in our walking styles, which may have affected our intellects, is seen in the few slight differences in our skeletons.
Here are two skeletons of modern primates. This skeleton I'm sure you all recognize because it's a skeleton like yours and mine. This is a modern human. But this smaller skeleton is one of our closest living relatives, the chimpanzee. We began walking on two legs, and that made a whole series of modifications in the skeleton. In humans, the spinal cord comes out of the base of the skull and points straight downwards, rather than coming out of the back of the skull. The pelvis is shaped very differently. A chimpanzee has a long, narrow pelvis. Ours is short and squat. We walk with our knees close together. Chimpanzees walk with their knees wide apart. These are minor differences. These are the sorts of tinkering that evolution did to change us into a modern biped.
What if our ancestors hadn't stood up? What if they had taken one different turn along the path to becoming human?
One of the great misconceptions that most people have is that once our ancestors stood up, it was almost inevitable that we would be here today, that the egocentric species, Homo sapiens, would evolve in this manner. But what we see is that evolution has worked the same way with us as it has with every single organism on this planet. We're here through a series of chance coincidences, specific adaptations, chosen opportunities. So I think that when we look at our own origins, we see that it is extraordinary that humans are here to look back and ponder their past.
Does that mean we are not unique in many ways? Of course not. We're the ones telling this story. And that's very important. That evolution, that life has gotten to the point where it can tell this story.